What is ophiolitic melange? Ophiolites are sections of oceanic lithosphere that have been abducted, or uplifted and exposed on land, due to tectonic processes such as subduction. They represent a rare opportunity for geologists to study the deep structures of the oceanic crust and upper mantle that are typically inaccessible. Ophiolites consist of a suite of rocks that are typically found in the oceanic lithosphere, including basalts, gabbros, peridotites, and sheeted dikes. These rocks provide important insights into the processes that occur beneath the ocean floor, such as volcanic activity, magma intrusion, and mantle melting. Ophiolitic melanges, on the other hand, are geological units that consist of a chaotic mixture of different types of rocks and sediments that are typically associated with ophiolites. They form when the oceanic crust is subjected to tectonic forces, such as subduction, and is then mixed and jumbled together with other types of rocks and sediments. The resulting mixture can include fragments of basalt, gabbro, peridotite, and other types of rocks, as well as various types of sediment, such as sandstone, shale, and limestone. Ophiolitic melanges are typically found in areas where ophiolites have been thrust up onto land and have been subjected to intense tectonic deformation. They can be important indicators of past tectonic processes, as they provide evidence of the complex deformation and metamorphism that can occur in subduction zones. Ophiolitic melanges are often studied by geologists to better understand the geological history of a region. By analyzing the composition and structure of the rocks and sediments within the melange, geologists can gain insights into the past tectonic processes that shaped the region, including the timing and direction of subduction, the intensity of deformation, and the extent of metamorphism. Overall, ophiolitic melanges are important geological units that can provide valuable information about the processes that occur beneath the ocean floor and the tectonic history of a region. They are a testament to the dynamic nature of the Earth's crust and the ongoing processes of plate tectonics that shape our planet. How is ophiolitic melange formed? Ophiolitic melanges are formed through a complex interplay of tectonic processes, including subduction and accretion. Subduction occurs when one tectonic plate is forced beneath another plate, typically at a convergent plate boundary, where two plates are colliding. As the oceanic lithosphere is subducted beneath the overriding plate, it begins to melt and form magma, which can rise up to form volcanic arcs on the surface. In some cases, portions of the subducted oceanic lithosphere may become stuck to the underside of the overriding plate, forming an accretionary prism. This process can result in the formation of ophiolite sequences, which consist of sections of oceanic lithosphere that have been abducted, or uplifted and exposed on land. During the process of abduction, the ophiolite sequences can become highly deformed and mixed with other types of rocks and sediments, resulting in the formation of ophiolitic melanges. These melanges are typically formed in the transition zone between the subducting oceanic lithosphere and the overriding plate, where intense tectonic forces and high temperatures and pressures can cause the rocks and sediments to become mixed and jumbled together. The exact processes that lead to the formation of ophiolitic melanges can vary depending on the specific tectonic setting and the nature of the rocks and sediments involved. However, in general, the formation of ophiolitic melanges is thought to be a result of the intense deformation and metamorphism that occurs during subduction and abduction processes. These melanges can be important indicators of past tectonic processes and can provide valuable insights into the geological history of a region. Please don't forget to subscribe to my channel and turn on notifications.